When we're thinking about the growth of a population in a given place over time, we can often think and look at resource availability to try to understand what can happen with that population. This relates to the last topic, carrying capacity. Usually there are environmental factors that limit the growth of a population, that establish a carrying capacity for a given resource. If resources are finite or limited, and typically there's a maximum population size that can be supported. And what we often see is that in the early stages of the growth of a population, there's very rapid growth, okay, because resources are abundant for a relatively small population size. But as the population grows, finite resources begin to be used up. And that lack of resources can lead to a population growth leveling out or even declining. When there's limited resources available for species, we can have increased mortality, we can have decreased birth rates, we call that fecundity, and that affects the growth of the population over time. When we are thinking about the predicted growth of a population, we have an equation that sometimes is used. The change in the population, dn over dt, over time, is a product of the reproductive rate of that organism and the number of organisms present. And so if we only include those two factors, we have R, which is the per capita growth rate. Okay, so that's just sort of a characteristic of all populations. All populations have an intrinsic growth rate. We label it R. And so if we only take into that maximum reproductive rate multiplied by the population size, the graph of that type of growth, we call that exponential growth, increases exponentially over time. Another model of population growth adds in some more complexity. This is called logistic growth. We still include the population size and we include the reproductive rate, but we have an additional factor. Okay? And this additional factor is the carrying capacity, okay, minus the population size divided by the carrying capacity. And if we use this equation to approximate population growth, what we see is an increase pretty quickly until this population growth reaches the carrying capacity, and then it reaches its limit and approaches the carrying capacity here. So those are two different models of population growth, and we can use those to approximate the growth of a given population over time.